I'm going to go through a few more questions from exercise 12.2 to do with quadratic inequalities. And there's a variety of different ways in which you could approach this question. On many levels, it's actually a functions question, and there's a lot to be said for drawing the graph accurately. And if you had your negative quadratic, and let's say it was that curve there, okay, and then if you drew it accurately, obviously, and graphed it properly, and then what values for f of t being less than or equal to 4, so that was 4, you could sort of read off values that would fit the curve. I mean, you could do the whole thing as a functions question, draw it accurately, and so. But in many respects, this question does lend itself to an alternative approach. If you just realize that the core statement, start off with the first one here, f of t is less than or equal to 4. So let's just write that out. There's f of t, it's given us as a function, so minus 11 plus 13t minus 2t squared, and we're being asked when it is less than or equal to 4. So let's just rearrange that. Okay, if you remember, when you've got an inequality, if you make it equal to 0 and work on that that new inequality, you'll get your range of values that fit the criteria. I'm taking the opportunity when making it equal to 0 to bring everything onto the side where the t squared term will be positive, just because it'll make my life a lot easier. Okay, solving that as a positive quadratic being greater than or equal to 0, okay, is a process that shouldn't be, I suppose, too difficult for me. So again, let's just write it the other way around, so it's sort of in the format that we're more used to. That's greater than or equal to 0. Okay, I've turned the whole thing around, including the direction of the inequality. So this is the quadratic that I'm going to solve. So what two numbers multiply together make 30 and add together to make minus 13? That'll be minus 10 and minus 3. So when factorized, it becomes t minus 5, 2t minus 3, being greater than or equal to 0. And from that, you're able to get critical values of 5 and 1.5. So the only thing now we need to decide is it between these two values or outside of these two values? So let's again think of our quadratic. We can go with any of them. Okay, in many respects, we've been working on this quadratic here being greater than or equal to 0. So we could look at this one here now. In fact, it would be the same as looking at the previous one. But what values give us something greater than or equal to 0? So if we think about this positive quadratic, cutting at 5 and 1.5, when is it greater than or equal to 0? Okay, that's going to occur when it's above the x-axis. Therefore, you want values of x that are greater than 5 and less than 1.5. So my solution is t must be less than or equal to 1.5, and or greater than or equal to 5. So again, if you want to be absolutely perfect about this, you'd say it's the union of those two scenarios. Okay, it either has to be less than 1.5 or greater than 5, greater than or equal to 5. The second part uses exactly the same process with a different inequality where it's greater than or equal to 7. Once you've gone through that process, you'll end up with a solution of t fitting the criteria of between 2 and 4.5. So I just want to quickly discuss the third option, third question. Okay, where we're being asked to deal with when is f of t between 4 and 7. Now, if you look at the first two parts, we first are asked when f of t is less than or equal to 4, and we were then asked about when is f of t greater than or equal to 7. So you can see this third scenario is just the remainder of the range of values that f of t produces. So we just basically want everything that doesn't fit the criteria that have been listed in our first two solutions. So what doesn't appear in these boundaries. So a number line is a fairly good way of being able to sort of look at this. So we can see that all values that are less than or equal to 1.5 or greater than or equal to 5, they're already dealt with. We've got values between 2 and 4.5 inclusive. So what we're left with is a very small gap. We've got one section which refers to values that are between 1.5 and 2, not inclusive because they've already been covered by the two original solutions. And likewise up here we've got anywhere between 4.5 and 5. So again, any values between there meet the criteria of f of t being between 4 and 7. So again, I suppose to be absolutely perfect about this, we would union them. It's one or the other.